In this question here, we're being asked to use some data that's been gathered from an experiment and to use this to produce a graph. And the first thing we need to do with the graph is to sort out axes. We need to calibrate and label these axes, then plot the points, and then draw a line of best fit. We've got two variables here. One is potential difference and the other is current. And the convention is that the independent variable, the one that we're controlling, that we change the value of, that's the one that's going to go on the horizontal axis. So we need potential difference on the x-axis, and we need to choose a suitable scale. And the scales that I'm going to use for this is to have 2 volts for one large square. So we'll put 0 at that point there, and we'll put 2, then 4, 6, 8, 10, 12 there, and that will cover the full range of values because we need to be going up to 11.8. We also need an axis, a label on the axis here, so it's potential difference, and if we indicate that that's voltage that's on there, then that saves us from having to put a V next to each of those values. We now need to calibrate the vertical axis. This is the dependent variable, the thing that will change as a result, and this of course is current flow. And I've decided that the scale I'm going to use for this is 0.01 of an amp to 3 little squares. Generally speaking, it's a good idea to make use of as much of the graph as possible, so that scale will do that. So at that point there, I'm going to make that 0.01, count 3 little squares up, that's going to be 0.02, another 3 little squares is 0.03, another 3 little squares 0.04, 0.05 goes in there, and 0.06, which is the highest values that we need to deal with, goes in there. And again, we need to put a label on this axis. This is current, so we'll put in write in the word current and then indicate what it is that we're measuring that in, which is of course amps. We can then plot the points on here. A good way of plotting the points is to use a cross. The first of our points is 2.2 volts, which is just over, it's just halfway across one of the little squares beyond 2. 2.4 would be the whole of little square. This is 2.2. The current is easy to read on there. It's 0.01, and we'll show a cross. The reason why we use a cross is because the center of that quite clearly indicates where the value is. The next one is 4.1, which is just a little bit over. It's a quarter of the way across the next little square from the 4, and that's against 0.02. The next one is exactly 6. That's an easy one to plot there. So it's 6 volts, 0.03. 7.9, which is just under, it's a quarter of a little square short of 8, and that's against 0.04 amps. Then the next one is 9.9 volts, which is a quarter of a little square, less than 10 using that scale, and that's with a current of 0.05 amps. And then the final one, 11.8, that's halfway across one of the little squares there, just short of 12 volts, and that's against 0.06. So we got the points plotted with that. Now if we look at that, we can see that pretty much that they form a straight line. A line of best fit doesn't have to be a straight line, but in that case they do fall pretty much on the straight line. Notice here that we don't have a reading for 0 volts, so therefore that we don't know what the current at that point is. We might expect it would be 0, but we don't know because we haven't got that. So I'm not going to start the straight line at the origin. I'm going to draw a line that connects each of those points. I'll draw the line in like that, and then that shows what the trend is, the relationship there between potential difference and current.